In this video, we're going to provide a brief overview of limits. So the idea of a limit is that it's telling you to get as close as possible to a specific value, usually an input value, and determine as you get close to that value, what is the function doing? What output value does it appear to be approaching? So remember, if we're considering a graph, typically our horizontal axis is the x-axis. Those are our inputs. In the vertical axis, we're going to call f of x or our y-axis. That's our outputs. So what we're trying to do here, for instance, let's look at this first one. This is saying let x go to negative infinity. In other words, as you go very far to the left, remember, x is the horizontal axis. As you go out this direction to the left, what does the function appear to be doing? And in this case, you can see the function appears to be getting closer to the x-axis, which is an output level of 0. So we would say as we move out to the left as far as possible, this function is going to an output level of 0. Similarly, as we move out to the right, which is what this second limit is telling us to do, go out to the right as far as you possibly can and determine where the function is heading. This function is getting closer and closer as well to the x-axis, which is an output level of 0. Let's talk about this notation. X approaches 3, and then there's that small little negative sign. That's saying approach 3 from values to the left of 3. So what we want to do is approach 3 from the left and determine where the function is going. So as I approach 3 on the input axis, on the x-axis, where is the function going? The function is actually going to negative infinity. As x approaches 3 with the plus sign is saying approach 3 from values just to the right of 3 and determine where the function is going. So if we are just to the right of an input value of 3, we can see the function is taking off and it's going to infinity. Oftentimes, we want to look at functions that are written as fractions. We call these rational functions. So something that's written as one function divided by another function. And if the degree of f of x, if the top function has a larger degree than the bottom function, we say that the function, as it goes to positive or negative infinity, will also go to positive or negative infinity. If the function in the numerator has a larger degree, then the function will go to a value of 0 as we go to positive or negative infinity along the x-axis. And if the degree of the numerator and denominator equal, then the function will actually go to the ratio of their coefficients. So I know this looks a little bit wordy, so let's look at an example. So we're going to look at an example of each one of these scenarios. The degree we will talk more about in future videos, but it's essentially equal to the largest exponent associated with that polynomial term. So this has a degree of 3, and this has a degree of 2. That means this limit should go to infinity. If you notice on this graph, if you try and move to the right towards larger and larger values, the function takes off. This is actually the graph of this function. And you'll notice very quickly that the values get large. That means that this function, as we approach infinity on the x-axis, it's going to infinity on the y-axis. In this scenario, the degree of the numerator is 2, and the degree of the denominator is 4. Since the degree in the denominator is larger, we expect this graph to go to 0. Notice how as I move out to the right, the function is really just basically on x equals 0. So that means as we go out to the right, the function is also going to 0 as well. In this function, the degree of the numerator and denominator are the same, so this function should go to the ratio of the coefficients. It should go to 4 over 2, which is 2. Notice how as I move out to the right along the x-axis, this function value is just getting closer and closer to an output of 2. So this limit will go to 2. So we're just considering the degree of the top and the degree of the bottom. If the degree of the top is larger, it's going to go to positive or negative infinity. If the degree of the numerator is larger, it's going to go to 0. And if the degrees are the same, then like this case, it's the ratio of the coefficients.